So Amazon SageMaker is a machine learning environment. Let's take a look at how we use it. So let's log into the website. So here's my AWS account. I'm going to sign into the console. I already have used this before. So under services, we need SageMaker, Amazon SageMaker. Okay, so SageMaker allows us to build and train machine learning models. Let's first create a notebook instance. We're going to use Jupyter Notebooks, and we need to create a notebook actually in AWS. So we're going to run our Jupyter Notebook on the AWS site. So notebook name, let's call it John SageMaker 001. The cheapest machine is this machine. We can have choice of others, but this is the smallest one that it'll allow us to use. Let's not worry about elastic inference at the moment. You need to get a role, and I already set up this SageMaker execution role. But you'll need to do that. Get yourself an Amazon SageMaker full access, okay? And give root access to this notebook. I don't want any custom encryption. I do want to use a Git repository, and I want to clone a public Git repository into this notebook. And I happen to have copied this. So here it is, the SageMaker examples, and that will do. So let's create a notebook. So you see here, John SageMaker, and it's pending. It'll take a while to spin up. So I'm going to pause. It takes a little while for the notebook to spin up. So while that's spinning up, let me explain the problem that we're going to learn on. It's called cart and pole. And what we have is a frictionless cart that can move along this line, left or right. And balanced on top of it is a pole. And we want the machine to learn to balance that pole. Now, the initial condition is that this cart will have a velocity, and so the pole won't be in equilibrium. And we need to have basically a feedback mechanism to control that pole and keep it balanced. Now, instead of using a normal feedback control, we're just going to get the machine to learn how to control it. So if it tips more than 45 degrees, it fails. So it's going to learn that it mustn't tip over, and we'll get the machine to solve this problem. Let's go back now and take a look. Okay, so now we can open the notebook. So you see this notebook is on AWS, and now out of this notebook, we need to select reinforcement learning. And now we need to get the cart and pole coach. So we go into here, and here's the notebook. The source code is in here. So this is Python. These are Python files, yep. And so let's go into the notebook, because that'll tell us how to run it. So here we are. Here's the notebook. Now we need to set up the correct kernel. And the kernel that we need, so click on kernel. Here is Conda MXNet 36. And at the moment, the kernel isn't trusted, so we need to click on this and trust the kernel. Okay, we're trusted. So the first thing we need to run is this. Notice now it's trusted. I'm going to run that again just to make sure. Now we need to set up an S3 bucket. So let's see, it's doing that. It should return some output to us when there it is. We've got an S3 bucket set up. That's where we're going to dump the results of this calculation. Now run this job. We could run this on our local machine in a Docker container, but we're not. So we're going to be spinning up this instance type. Now this could use some CPU cycles that are not free. This is an ML.M4 large machine. Now let's run this. So this gets us the IAM role that gives us the security clearances that we need, the tokens that we need. We're not running local, so this won't do anything, but we'll just run it anyway. This is going to just list out the code that we're going to be running. So this is the Python file, and it's using this algorithm, this ClipPed PPO. So there we go. This just inlines the code so that we can read it. Skip over that for now. Let's just skip over it. Now let's start the training code. Again, it's just going to list it out. We haven't done anything yet. Now let's start running. So this one is going to execute. And let's store intermediate training points. And now this will help us visualize. So let's take a look. It's using matplotlib. So we probably haven't got any results. Yes, it's waiting now. So our program now is writing our results out to the S3 bucket. So here's the name of the bucket. We could go and look at it. Now let's render anything that we've got. We've got some output, it looks like now. Now let's try the visualization. And, okay, now we're beginning to get results. So let's rerun this. Okay, it's not doing very well at the moment. It's retraining and failing. Let's see if it can climb out of this a little bit. Okay, so this is now the GIF showing it learning how to balance this. It's not doing too badly, actually. Let's run this one again. We should be doing a little bit better than this. I'm going to run it once more. Okay, now it's beginning. Notice it's up to 160 now. It's climbing up. It's doing better. Let's visualize this one. There we go. This is a bit better. There you go. It's doing a much better job of stabilizing it. Yep. That's pretty good. That's pretty good. So that's an example of machine learning. Let's shut this down. So to shut this down, let's just run this one. And what I can do is shut down the server now that's running this. I've got one in service. Let me get that notebook and I'm going to stop it. Okay, so that's our first example using reinforcement learning. Okay, bye for now.